Happy day to all. This is Dr. Nivedita, co-founder and chief physiotherapist of Sri Ahana Physiotherapy Clinic and Academy. This video is on torque in biomechanics. Force applied on a body can bring about two outcomes. The first thing is translation, the other thing is the rotation. This depends in which plane the force acts. If the force is acting in a parallel plane to that of the segment, then the segment undergoes translation. If the force acts perpendicular to the axis of rotation, it brings about rotation of the joint or the segment. So now this perpendicular distance between the axis of rotation and the force is termed as momentum. The product of this force and momentum is the torque. Torque is nothing but the rotatory equivalent of a force. Any force that has momentum will produce rotation. A force that doesn't have momentum can cause only push or pull of the object in a linear fashion. To explain this concept, let us take a day-to-day example of opening the door. The hinge of the door forms the axis of rotation. Any force that acts parallel to this hinge can cause only translation, that is up and down movement. It can either compress or distract. It will not help in opening the door. So for a rotatory movement to happen, that is to open the door, you need a force that acts perpendicular to the axis of rotation and not the one that acts parallel, because remember, parallelly acting force can only cause compression or distraction. So when you have the axis of rotation and the force, if it acts perpendicular to the axis of rotation, then there occurs rotation of the segment, which is required for making the door open. This force that causes rotation of the segment is called as torque. There are two kinds of torques. One is the internal torque, the other one is the external torque. Internal torque is nothing but it is the product of internal force and the internal momentum. Internal momentum is the perpendicular distance between the axis of rotation and that of the insertion point of the muscle.
External torque is the product of external force and the external momentum.
Static rotatory equilibrium is attained when the magnitude of the internal torque and the external torque are equal. There occurs no rotation around the joint. At all times, there exists a competition between the internal torque and the external torque to dominate over the joint. More dominant torque is identified by the direction in which the joint moves. The interesting thing in this topic is the strength of a person. The strength of a person depends upon the muscle force. And equally important is the momentum, which is the perpendicular distance between the axis of rotation and the line of force. To explain this, let us take the example of biceps muscle. When you put the hand in complete extension, the momentum is the shortest for the biceps. So this position becomes the weakest position for the biceps muscle. As you gradually move up to flexion of 90 degrees, what happens is the momentum is the maximum here. So mid-range is the point where this biceps muscle is the strongest because of this reason. And as you gradually move up from 90 degrees, what happens is again the momentum becomes short. That is the distance between the axis of rotation and the line of muscle force, which is the point of insertion. It explains why the muscle is strongest at few points in joint range of motion. So, for a muscle to efficiently perform, the momentum must be more. The next interesting thing is the best of 3 elbow flexors. To know the best of 3 elbow flexors, first let us talk about brachialis. Brachialis inserts at an angle of 80 degrees and it is 1 inch away from the axis of rotation. Next we have the biceps, which inserts at an angle of 90 degrees and it is 2 inches away from the axis of rotation. Then we have the brachioradialis muscle, which is inserted at an angle of 20 degrees and is 9 inches away from the axis of rotation. Practically speaking, the moment arm of brachioradialis radialis is the highest. That is why most often in day-to-day activities we prefer lifting with mid-prone position and not the supination. So with this explanation you would have understood why we lift objects with mid-prone. Don't go for weightlifting which is done this way. Rather, look for day-to-day functional activities. Look for people carrying things. Heavy things are carried in the mid-prone position. I hope with this video you would have understood torque, momentum and lever. Thank you.